Okay, good evening. Let's look at this question 20.2. 3 events A, B, and C are considered. Probability of A is 2 over 5. Probability of A or B is 13 over 20. Now, these are the probabilities. Remember, they talked about A, B, and C, but here they're talking about what? A, B, and A or B. They haven't mentioned anything about C yet. 10.2.1. Are events A and B mutually exclusive? Support your answer with necessary question. So what do we know if about mutually exclusive events? If our answer is going to be no, therefore our result should be probability of A and B is not 0, meaning that if our answer is yes, probability of A and B is 0. That is our reasoning here. So now this is the question that I believe that everyone should get it correct if it appears in the exam. So now let's go and look for probability of A and B are mutually exclusive. So we need A and B. Once we see probability of A or B, think about probability identity that says probability of A or B, it is equals to probability of A plus probability of B minus probability of A and B. This is identity for probability. Now let's focus on this. This is 13 over 20. It is equals to 2 over 5 plus 1 over 4 minus probability of A and B. So in this case, now we're going to say 2 over 5 plus 1 over 4, which is 13 over 20. So it's 13 over 20. It is equals to 13 over 20 minus probability of A and B. Probability of A and B, it is 0, meaning that these events cannot happen at the same time. So the answer is yes. The reason is probability of A and B, it is equals to 0. Then we're done with the 2 marks. Now they say 10.2. Determine the probability of C only if it is further given that probability of A or C. Look at this. A or C. And remember I mentioned that once you see A or C, think about the identity. So probability of A or C should be equals to what? Probability of A plus probability of C minus probability of A C. That's the identity now. Here what are we given? Probability of A and C is given here. And probability of B, of 2 times B and C, it is equals to probability of A and C. This is B and C. So now let's focus on this. Now if probability of 2 B and C is equals to probability of what? Of A and C. We're given A and C. You see this? This probability of A is equals to this. So now we want to know the probability of what? Of C only. Now let's look at this now. What are we given in this case? Probability of A and B is given is 7 over 10 is equals to probability of A is given is 2 over 5. It's 2 over 5 plus that probability of C, we don't know, minus probability of A and C, which is 2 over 5. So in this case, this cancels that. So probability of C is equals to 7 over 10. But the question is now, find probability of what? Of C only. Now, what do we do in this case? Let's look at C. So now, it equals to everywhere where we find C. Everywhere where we find C. So the best way to do this, I want to draw the Venn diagram to show us exactly what are we dealing with here, so that you can see what we are dealing with here. Now, remember that the intersection of A and B is 0, but intersection of B and C is not 0 because it's 2 times A and C. So now that means that you can have my A there, C here, B here. So remember that this is A, this is C, this is B. So A and B don't intersect. That's like this. They will never intersect. So probability of A is 2 over 5. Then the intersection of A and C is 2 over 5 also. So they intersected. So this is part of C. That is part of C. So this is the first part of C. This first part of C is 2 over 5. Now the second part of C is 2 times this. So second part of C is B, and C is 2 times A and C. So now let's check if A and C is this, what is would be, so B and C should be A and C over 2. So true probability of B and C equals to probability of A and C. So true probability of B and C, it is equals to what? 2 over 5. So we divide by 2, this by 2, so it's 2 over 5. Okay, so now we're explaining that this part here, it will be 2 over 5 divided by 2, which is 1 over 5. So the intersection here, it's 1 over 5. So now we can see that C have 3 sections. We're looking for C only, which is this part. So C only, you have to be probability of C, which in this case is 7 over 10. It is equals to 2 plus 1 over C only. That's what you should know. So 7 over 10, it is equals to, this is 5, 3 over 5 plus C only. Therefore, that will give us C, it is equals to 7 over 10, 3 over 5. So C is equals to 7 over 10 minus 3 over 5, which is 1, 10, which is this 1 over 10. Okay, now determine the probability that event A, B, or C do not take place. So now what is outside here? What is outside here? Event A, B, or C doesn't take place. So now remember that we must focus on what's inside. So event of A only, we don't have it. Event of A only, we don't have it, because the event of A is equals to the intersection. So this here is 1 over 10. So the event of B only, we're gonna take B, event of B minus 1 over 5. We can find B only. Event of B is 1 over 4 minus 1 over 5. 1 over 4 minus 1 over 5, which this is 1 over 20. 1 over 20. So now, not in A or B or C, we're just going to say its probability of, it's going to be 0 plus 2 over 5 plus 1 over 10 plus 1 over 5 plus 1 over 20. Let's see the probability of those events happening, which is 2 over 5 plus 1 over 10 plus 1 over 5 plus 1 over 20, which in this case what do we have here? We have 2 over 5 plus 1 over 10 plus 5 plus 1 over 20, which we have 3 over 4, which is 3 over 4. So probability of not is 1 minus 0.75, which is 0.5. That's how we work on this.